So the topic we'll look at today is relating to functions and increasing and decreasing functions. And we're also going to talk about the average rate of change. So when we talk about increasing and decreasing, we're talking about functions from the left to right. What is the function doing? So if you look at this figure one, so from left to right, I can see, like I'm going to look and see where it's increasing first. I can see from left to right, from A to B, it's increasing. And the way I write these, when we write intervals, so I'm going to write the interval from A to B, we're talking about these x values. So we're never talking about the y values, capital A, capital B, C, and D. We're always talking about x intervals. So one interval where it's decreasing is from A to B. And that takes us to this uppercase B. Between B and C, if I can just draw an arrow on the function, it is going down, so it's decreasing. So the function is decreasing on the interval from B to C. Okay, and then we look at the last one. From C to D, the function is increasing again, so we would put that up here. So it's also increasing on the interval from C to D. So this is pretty intuitive. If you look at an image, if from left to right it's increasing, it's increasing. If it's decreasing, it's decreasing. So let's look at an actual function then. Oop. So this is the function x to the 2/5 power. So it creates this bird shape. So you can see that that function is increasing and decreasing. Like it's increasing on the right, decreasing on the left. And so just like the last example, we would just say the function is decreasing from -infinity to 0 and increasing from 0 to infinity. So that function is continuous. So even though there's a scale here, we don't really care about the scale because it is a continuous function. And just one note about the notation here. These are brackets, or not brackets, they're parentheses, because at 0, x equals 0, this function comes to this point. That's called a cusp. So when it comes to a sharp point like that, we can't determine whether it's increasing or decreasing. So we exclude that value, which is x equals 0. Next topic we'll look at is the average rate of change. So the average rate of change is the change between 2 points on a graph. So in this picture, this dashed line represents the average rate of change, and we call that the secant line. So it's just a line that goes between 2 points on your function. And this is the graph of f of x, the blue line. So what I wrote here, this f of b minus f of a, that's the change in the y value. And b minus a is the change in the x value. So really what we're talking about, that secant line, is simply the slope. So if I zoom out a little bit, I'm just going to scroll down. I'm going to read this. The average rate of change is the slope of the secant line that passes between a, comma, f of a and b, comma, f of b. So to find the average rate of change, you calculate f of b minus f of a divided by b minus a. And this has a lot of different names. So one would be the slope. If you're looking at a linear equation, this is m. If you, instead of using f of b and f of a, use y's and x's, this is the same as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So this is really just the slope, and the only difference here is that we're using function notation to notate it. So let's look at an example of that one. Let me Okay, so let's use the average rate of change here. We're going to find the average rate of change of the function x minus 2 squared between x equals 6 and x equals 4. So I'm going to write out the average rate of change right here. Okay, so basically we're going to plug in 6 and 4. And it doesn't matter which one you call B or which one you call A, but let's just call this B. Let's call this A. Okay, so we're evaluating the function at B and A and then dividing by the difference between B and A. So let's start. So f of B, if I'm saying B is the value 6, f of B would be 6 minus 3 squared. That's f of B. Minus the value of f of A. And A is 4, so we'd plug in the 4 for x and go 4 minus 3 squared. Divided by B minus A, which is just 6 minus 4. And once we do that, we just simplify this. So 6 minus 3 is 3, squared is 9, 4 minus 3 is 1, squared is 1, divided by 2. So this would be 8 over 2, or 4. So the average rate of change between 6 and 4 is the value 4. So 4 is the slope value of the secant line. All right, the next example we'll look at is just a visual of this. So here is some graph with a dashed line between 2 points. So if you were told to find the average rate of change between, let's say where the dots are, so x equals 0 and x equals 5. Okay, so I've seen a lot of different attempts at these problems. Students complicate them. You don't have to complicate this. The average rate of change between x equals 0 and x equals 5 is the slope of the secant line. And the slope of the secant line is this dashed line. So you don't have to use any formula or anything. You're just looking to see what the slope of that line is. And if I choose a different color, so the slope of that line would just be rise over run. And what is that? So the rise would be, 1, 2, 3, 4. And the run is 1, 2, 3, 4, 5. So the average rate of change between x equals 0 and x equals 5 is simply rise over run, or 4 over 5. So 4/5. So any of those problems in your book that show a graph and a dashed line, you really are just finding the slope of that line.